Let us first write the element corresponding to this sigma, and for that I write here 1 corresponding to this will be row 1, 2, and below it will be row 2, sorry, sigma 2. Thereafter 3 sigma 3, 4 sigma 4, 5 sigma 5. Okay, and according to this question, and this will be 1, and you see sigma 1 is 2, so below 1 there will be 2, accordingly here will be 2, here will be 3, and 3 below it will be 1, and thereafter 4, here will be 5, and 5, and below it will be 4. Okay, so we got the element of this symmetric group S5, and now we see we should read this one. What does it say? It say this is our row. Okay, so we have to find tau, this tau, which commute. You see the relation, this relation means commutativity holds. Okay, so we have to find those elements named tau which commute with this element sigma. Okay, so let us get those elements. And first element, in any group, whether it be a symmetric group or any other group, the identity element commute with all elements. So the first will be, in this set, the first will be the identity element. Okay, now the next elements are there or not. So symmetric group is not an abelian group. Okay, so all elements do not commute with another element, but there are some elements, and that commute due to associativity nature of the group. In any group associativity hold. Okay, and before going to find those elements, one thing here you observe that in this element you see here this part and this part, these two parts, you see those two red circles. In those two red circles, the numbers are distinct. I mean, in one circle, if there is 2, then that 2 is not in the another red circle. So this element sigma can be rewritten as 1 2 3 2 3 1 4 5, and here will be 5 4. Okay, so this one I show you in green underline. This one and this one both are the same. Okay, but this one is the simpler form. This says that it is disjoint cycles of 3 and 2. Okay, because in the first you see 3 numbers 1 2 3, and in the second you see 2 elements 4 and 5. So we have written the first element, that is the identity element, the simplest element. Now we find another elements. So before going to find those elements, suppose A is an element. Okay, and A cube will be obviously an element of the same group, and this can be rewritten as A square or A square A. Now look at this. What you observe? You observe that A square is commuting with A, or you can say in other word, A is commuting with A square. So in for any group, whether it be abelian or not, an element and its power may be 2, 3, 4, all those powers commute with the elements. So so far, so we learned that we have to find the powers of these two disjoint cycles. We have to power, okay, we have to find the power of these two disjoint cycles, and those elements will commute with this sigma. So the next element we can write 1 2 3 2 3 1 itself, okay, because we can write a dot a equals to a dot a is commuting with a, okay. The next will be its power, that is 1 2 3 2 3 1 to the power 2, okay. We cannot write the power 3 of this, the power 3 of this, or precisely we say power 3 of this will give you this element, identity element, and we have already included the identity element, so we will not take the power 3 of this element, okay. Now we have taken the powers of this part. Now we will take the power of other cycle, that is this one 4 5. So what will be the next element? So the next element will be 4 5 5 4 itself, okay. And the next element, we cannot take the power of these two, because power of this 4 5 5 4 power 2 raised to the power 2 will be an identity element, because 4 5 5 4 this one is an element of order 2. So element of order 2 will give you the identity element which already have been taken, okay. So now we will take the combination of these two, so the next element will be the same element, the sigma, and this will be 1 2 3 2 3 1 4 5 5 4, okay. And the last one, there will be one more element, and that element will be combination of those two, but the power of the first cycle will be raised to 2, 4 5 5 4, okay. So we got the elements which commute with this sigma, okay. So now the question says find the number, so we have to count the elements. The first element is this identity element, the second is this one inside the blue circle, third is inside the blue circle, you see now third, and fourth is here, fifth is here, and the sixth and the last one is here. So the total number of such elements will be 6. So here in the vacant place we have to write 6. So this